Welcome to this UPCAST training session that covers the essential concepts of monitoring and compliance in data sharing processes. In this session, we will explain why monitoring and compliance are necessary services to track activities and how these two services can be used to check compliance of data processing workflows with the terms of contracts that have been agreed between data sharing entities, namely data provider and data consumers. We start this training by explaining the core concepts of monitoring and compliance, and give a motivation why the two services are needed in data sharing processes. Then we will show how they can be put in use and what output they produce. Monitoring underlies all everyday activities. We monitor work to ensure adequate performance. We monitor health to ensure we remain in healthy condition. We monitor energy consumption to ensure energy spending remains within limits. We monitor traffic in cities and rural areas, stock prices, and so on. The purpose of monitoring is to collect data of interest from a monitored subject and send them to other services for processing. In UPCAST, monitoring relates to data sharing activities. For example, when a data set is priced by the pricing plugin, or negotiated by the negotiation plugin, or even processed by an execution engine, monitoring data are collected. These data are used to check compliance of the data sharing activities to regulations in force, or even check compliance of the processing of the dataset with contractual terms that have been agreed between the dataset provider and dataset consumer. In this session, we will go over the details of the monitoring and compliance services as they have been elaborated in the UPCAST project. The agenda of the training session is as follows. First, we are going to give an overview of monitoring and compliance. Then we will give a motivation why monitoring and compliance matters for SMEs. Then we will go to the details of the monitoring and compliance service and explain how it is structured. Then we will give a demo of the service and explain the results produced. We close the training session with pointers to resources and further reading. Let's now explain some details of the monitoring and compliance. Monitoring is a core function of any system, be it automated, semi-automated, or manual, ICT-based or not, and so on. Monitoring involves two entities, the monitored system and the monitoring service. The purpose of monitoring is to collect data from the monitored system over a time period for further analyzing them. Monitoring data may be of diverse types, and may be environmental data, financial data, health data, market data, performance data, and so on. Monitoring data can be used for assessing properties of the monitored system, like the quality of the atmospheric conditions, performance and security of a robot, compliance to traffic regulations, analysis of market trends, and so on. In this training course, we will focus on the actions of data sharing, in particular the processing of a dataset under the terms of a contract that has been agreed between a dataset provider and a dataset consumer. The focus is on monitoring of the execution of a dataset, meaning collecting events during its processing for further analysis. Execution takes place under the terms of a contract. Therefore, we will focus a particular analysis we perform on the monitored data, that is checking compliance of the monitored execution with the terms of the contract between the dataset provider and dataset consumer. There are three reasons why monitoring and compliance is important to SMEs. First, in today's digital economy where all transactions take place electronically, SMEs want to guarantee they remain compliant with regulations in force in all data sharing operations they carry. Therefore, they need a means of logging their actions so that proof of compliance can be produced easily. Second, as data owners or data providers, SMEs want a guarantee that any consumers have used their data according to their policies and the agreements they have signed with them, retaining thus controlled use of their valuable data. Therefore, they need a means of providing guarantees that data consumers remain compliant with the terms of the agreement they signed with them. Third, as data consumers, SMEs want to be able to prove that the use of the data they have acquired from a dataset provider does not violate any terms of the contract that they signed with them, providing thus a guarantee for any subsequent audit on the use of the acquired data. Let's take a look into the context in which monitoring and compliance have been developed as services in the EU-funded project UPCAST. The Monitoring and Compliance Service is an integral service of the UPCAST platform. The UPCAST platform facilitates data sharing between dataset providers and consumers by integrating a number of reusable and easily deployable components called plugins. The main entities of the UPCAST platform are dataset providers and dataset consumers. Optionally, a data sharing platform may be used as well. Dataset providers may use several plugins to annotate their datasets, possibly with semantically rich metadata, price their datasets, and calculate the environmental impact when they are processed. They may also advertise their datasets to a plugin that has been developed for that purpose, or even to commercial or scientific data sharing platforms. These functions can be used as standalone ones, or they can be accessed through the provider dashboard. Dataset consumers may search for datasets they want to analyze using the Discovery plugin and providing a multitude of search criteria. Once a dataset is discovered, the dataset provider is contacted, and a negotiation between the two commences for specifying the terms of use and access to the dataset of interest based on the provider's and consumer's policies and existing regulations. If the negotiation is successful, a contract is produced and signed by the two negotiating parties. Dataset discover and negotiation can be used from the UPCAST consumer dashboard. This dashboard can also be used for specifying the processing workflow on the dataset. After a contract is signed, the dataset is transferred in a secure manner from the provider cloud, where is stored to the consumer, and processing can start. The UPCAST platform provides guarantees for the compliance of the dataset execution to the contract that is agreed between the dataset provider and dataset consumer. For this, monitoring events are emitted by the dataset execution and are fed to the compliance service. In the following, we will discuss details of the monitoring and compliance service. Let's now take a look into the main functions of monitoring and compliance. The monitoring and compliance service provides three main functions. 1. Collecting events that are emitted from the execution of a dataset. 2. Checking if execution of a dataset is compliant with the terms of the contract that has been agreed between a dataset provider and a dataset consumer. 3. Generating compliance reports to report on rule compliance and rule violations. We now turn to see the internal structure of the Monitoring and Compliance Service. The Monitoring and Compliance Service is a standalone service that has been easily integrated into the UPCAST platform. Monitoring relies on Apache Kafka, an open-source distributed event streaming platform for high-performance data pipelines, streaming analytics, data integration, and mission-critical applications. Kafka implements a publish-subscribe model of communication, a messaging pattern in which publishers send messages to topics, and subscribers express their interest to read messages from topics. Kafka topics are the fundamental units of organization for messages and are designed for high scalability and parallelism. They are ordered, immutable logs of messages, with each message having a key that acts as an identifier and a values that acts as the message data. Kafka provides for a highly flexible integration infrastructure, as publishers and subscribers can communicate through topics without knowing each other. UPCAST monitoring data are sent to the Kafka topic UPCAST. Each such message comes from a certain execution under an established contract. The key of each message is the pair contract number and execution number. The value of each message is the monitoring data the dataset execution sends. Compliance is implemented by a compliance server. The server reads messages from the Kafka topic UPCAST. Messages that are sent to the topic UPCAST have as key the pair contract number and execution identifier. The compliance service identifies the contract under which the execution sends the monitoring data and checks the compliance of the monitoring data against the rules of that contract. To support its function, the compliance service makes use of a NoSQL backend database, MongoDB. The database has two collections: the rules collection that contains the rules of the contracts that have been signed between dataset providers and dataset consumers. Each element of the rules collection is identified by the contract number from which it comes. The second collection contains the compliance reports that are generated by compliance service itself. The compliance service generates compliance reports CRS for each pair of contract number and execution ID. Compliance reports are JSON objects that contain the compliance assessment of the compliance service for the particular execution under the given contract. The produced compliance reports are sent to three targets: A, the Kafka topic UPCAST _CRS, B, a configurable HTTP port endpoint, and C, the backend MongoDB. Therefore, the compliance service is highly flexible and integrable to any platform, like UPCAST, that needs to assess the compliance of executions. Let's now take a look into how the monitoring and compliance is integrated with the other services of UPCAST. The monitoring and compliance service is easily integrated with the negotiation plugin. At the end of the negotiation plugin produces a contract that is an agreement between the dataset provider and the dataset consumer on the policies and terms of access and use of the dataset. The agreement is expressed in the Open Digital Rights Language, ODRL, a language for expressing policies that is developed by the World Wide Web Consortium, W3C. The rules of the generated contract are automatically translated to the formalism that is recognized by the compliance service and are then uploaded to the rules collection of the backend MongoDB that is used by the compliance service. We now take a look into the rules that the compliance service can process. The formalism of the rules accepted by the compliance service is quite simple. Each rule file pertains to a single contract and contains a list of rules. Each rule is a triplet. The first element of a rule specifies when the rule is to be checked. That is at the start or end of the while workflow execution, or the start or end of an action. Execution. The second element of a rule specifies its context, i.e., to which action it applies. For example, action start integrate means that the rule applies to the start of the execution of the action with name integrate. Similarly, action start asterisk means that the rule applies to the start of the execution of any action. The asterisk here is a placeholder. Moreover, action start asterisk tilde anonymize means that the rule applies to the start of the execution of any action except the action with name anonymize. The third element of a rule is the predicate that must be checked. For example, $ preceded underscore by anonymize means that the execution of action anonymize must precede the start of the current action. Likewise, timestamp less than or equal to some fixed time means that this action must complete before the specified time. The compliance rule language supports a number of primitives that are expressed by using the symbol $. The output of the compliance service is the creation of the compliance reports, one for each execution under a certain contract. The compliance reports are JSON files that contain information on the satisfaction or violation of rules of the contract under which the dataset execution takes place. For each monitoring event received, the compliance report contains the corresponding compliance logs, which is a list of the rules that have been applied and the outcome of their evaluation. The example on the right shows a sample compliance report for execution with ID 1 under contract 1234. The generated file is rather long, so only excerpts of it are shown here. The second excerpt of the same compliance report shows part of the result of the evaluation at the start of action read data. One of the rules that were evaluated requires that the name of the action be either A or B. Obviously, this rule is not satisfied. The result is contained in the compliance log as an alert entry that signals rule violation. The same part of the report contains the rule number, the context of the rule, and the predicate that was evaluated. We now give a demo of the monitoring and compliance service. The demo is given in 3 steps. Step 1 presents the operating environment of the monitoring and compliance service. It also shows the execution of a sample workflow that results to the generation of monitoring events, and then it shows how these events are pushed to Kafka topic UPCAST. Step 2, show the formalism of the compliance rules by explaining its syntax and semantics. It also shows how compliance rules are pushed to the compliance service. Step 3 shows the processing of monitoring data and generation of compliance reports. Let's now switch to the demo.
Hello and welcome to this demonstration of the UPCAST Monitoring and Compliance Service. We start the demo by first presenting the environment in which the service operates, in particular Apache Kafka and MongoDB. We check the status of these two services by executing systemctl status Kafka. So Kafka is up and running, and we do the same for Mongo. So Mongo is up and running as well. Next thing, we are going to connect to Mongo by just using the Mongo shell. Now we are connected to the Mongo server, and we ask to see the databases. So these three databases are the ones that come with the Mongo installation itself. In particular, no database has been created by UPCAST itself. Next thing, we are going to take a look into the Kafka topics that currently exist. We do so by executing the script upcast list that lists the currently used topics by Kafka. The two ones which are shown here are the ones which are, let's say, used by Kafka for its own bookkeeping purposes. So no upcast topics have been created so far. We continue with the main part of the first step of this demonstration, which is the execution of a workflow and the emission of monitoring events from it. To do so, we make use of a simple workflow, which is shown here. So it is expressed in a very simplistic language that contains actions, contains loops. It also contains conditionals, even though no conditionals are used in this particular example. And the idea is that, actions are executed in sequential order. So the first action is executed first. So this is the name of the action, read data, the parameters of the action, data file that come in a list, and the container that implements this action. After read data, then check validity, then the loop is executed. It first executes check validity, which will return either success or failure. Check validity checks the validity of this data file. And if it returns success, then the workflow continues with the next action down here, integrate, build model, and generate a report. If check validity returns failure, then we go into the body of the loop and we execute this action, cure data, on the data file in an attempt to cure the data of that data file, and then we go back to check the validity, and so on and so forth. So the loop executes while check validity returns failure, and when check validity returns success, then we continue with the following actions of this workflow. So this is a very simple workflow language, and we have developed an interpreter to execute workflows expressed in that language. So the interpreter is the one which is shown here, and we try to execute it on purpose. We execute it with no arguments, just to get feedback of what arguments it expects. So to execute a workflow, we need to specify the name that contains the workflow itself, the number of the contract under which the workflow executes, the execution ID of this particular execution, and then the groups under which the workflow is attempted. So next we are going to provide all these parameters which are expected. So the workflow is workflow 0. Let's say that the contract number is 1, 2, 3, 4. Let's say that the execution ID is 1. And then let's say that the groups is ADM. And then we go right and execute this workflow. Now the execution of the workflow results in these logs, which are generated by the interpreter itself, that present right the generation of the monitoring events and the execution of the actions themselves. So for example, the very first event which is generated is the start of the workflow. The very last event which is generated is the stop of the workflow. Moreover, before the execution of an action start event is generated, and right after the completion of the action, an action stop event is generated. Each one of those events contains two parts. The key of the event is the contract number, execution number, whereas the value of each event is information, right, which is let's say collected by the execution itself, right? So for example, here the value of this monitoring event says that this is an event that relates to the start of an action of this particular action which has been attempted on these parameters, right? And then the group under which this action is executed. So this is the result of interpreting this workflow. Let's go back here and see what is the Kafka topics that currently exist. So as we see, a new topic by the name UPCAST has been created, in which all the monitoring events that we saw before have been pushed. Now we're going to take a look into the contents of this topic. We do so by just executing UPCAST consumer. This is another script. We provide the name of the topic, right? And then we get back the contents of this topic, the messages of this topic, right? Which are the ones, right, that are shown here. And they are similar to what we saw before, right? So the key of each message is the contract number, execution number. Same goes for all messages that come from the same execution under the same contract. And then the value of each message contains all this information. So this comes, this is a monitoring event that is automatically generated by the monitoring service. It is the start of the workflow. It also has a timestamp. The next event is the start of the read data action with those parameters, right? Some additional information, right? With that timestamp. The next one is the end of the read data action with some parameters, timestamp, and so on and so forth. And the very last message which is generated is automatically generated by the monitoring service. It is the stop of the whole workflow. So these are the events which are pushed into the Kafka topic UPCAST as a result of the execution of the particular workflow that we saw before. That was the workflow under contract number 1234 and under execution ID 1. In the following, we are going to take a look into rules that can be expressed as a result of the negotiation of the use and access to that dataset between a dataset provider and a dataset consumer. We are going to see how those rules can be expressed and how they can be used for checking the compliance of the execution as is presented here with what those rules specify. Now we are going to take a look into the rules that are recognized and processed by the compliance service. To do so, we switch to the folder rules, right? And then we take a look into a sample rule file, the one which has the name rules_1234. So the name of the file that contains the rules has to be in this form, rules underscore, and the ID of the contract for which those rules apply. So let's take a look into the contents of this file. So this is a rule set that comprises a list of rules. Each rule is a tuple. It has three elements. The first element specifies at what point of the execution the rule should be checked. So here we check the rule at the start of the whole execution, at the start of the whole workflow execution, here at the stop, the end of the workflow execution, and then at the start of an action or at the stop of an action. The second part of each tuple specifies the context in which the rule applies. So, for example, here the context is the whole workflow, whereas this action start, the context of this particular rule is integrate. Only when the integrate action starts, this rule is to be checked, right? Or if the action integrate, right, at the stop of the action integrate, this rule will be checked. So this star is a placeholder, meaning that it applies to any action, whereas this construct over here specifies that the context of this rule is all actions except anonymize. The third element of each tuple is a predicate that has to return either true or false, and the outcome of this predicate signals the satisfaction of the rule or the failure of the rule. In those predicates, we use a number of built-in operations. So, for example, the dollar preceded by, which means that this action over here has to be preceded by the action anonymized, right? So meaning basically this imposes a sequencing between the actions. So first the anonymized action has to be executed, and then the integrate action, right, has to be executed. Yes, this rule, this predicate specifies that the 0th parameter of this action has to be a name between A and Z. For example, whereas this particular rule says that the name of the action must be either A or B. And so on and so forth. We can also express conditions on the container that implements an action. We can also specify conditions on the return value of an action. We can also specify conditions as timing of the action is concerned. So, for example, in this rule, we specify that the integrate action has to be completed by this time. So the predicates can be complicated, complex, or meaning that we can have, let's say, conjunctions or disjunctions and so on. So all the operators, right, that can be used in a, let's say, normal Python expression. So this is the form of the rule set. This is the formal which is recognized by the compliance service. We can write those rules either by hand, like it is the case of this rule set that we see, or we can translate those rules from ODRL expressions, which are contracts which are generated by the negotiation plugin. So the next thing that we see is how we can push those rules into the compliance service, right? So for this, we make use of a script, UPCAST upload, which takes rule set and then it pushes it to compliance. So compliance, the compliance service can make use of this rule set to check executions which are attempted under the specific contract number. Right? So to do so, we simply execute Python 3 upcast upload and then the name of the contract, the ID of the contract, 1234 in this particular case. So now the rule set, which is printed on the output, has also been pushed on the MongoDB. So if we take a look into the MongoDB and we ask to show the data bases, we see that a new database called UPCAST has been created as a result of pushing this rule set to compliance. So we switch to UPCAST and then we ask for collections. Okay, and then we see that a collection by the name collection.rules has been created. Okay, so now we are going to check the contents, right, of this collection. So we ask for db.collection.rules rules dot find, right, to see what is there. Yes, and then we see that a rule with ID 1234, right, has been pushed, and this is a textual representation of the same file that we saw before that contains the rules. So this file will be parsed by the compliance service, and it will be used to check the compliance of executions that are attempted under the contract 1234. In the next part, we are going to see how compliance behaves and how the monitor data are processed so as to generate compliance reports. Now that we have seen how monitoring events are generated from a dataset execution and how rules are pushed into the compliance service, let's take a look how the compliance service itself works and what output it generates. As it was noted before, the compliance service reads events from the Kafka topic upcast. It applies the rules that have been agreed under a certain contract number, and it generates compliance reports which are fed back into the backend MongoDB, but also they are pushed into the upcast CRS topic, Kafka topic. So let's see, to start the compliance service, we only need to execute the script, the corresponding script. So we do so, and then the service starts, and this is the first results that are produced by the compliance service. So if we go up here, so we see that the service has started, and then it outputs here on the screen the events that it received. So the first event that it has read from the upcast topic has key 1234, the contract number and the execution number. The source is the monitoring service itself. It is the start of the workflow which happened at that time, and then it gives us some information, right? So that while this event matches the very first rule in the rule set that the number of executions must be less than 2, it also matches the second rule of the rule set that the number of failures of the execution must be less than 3, and so on and so forth. So the next event generated under the same contract and the same execution number is the reader, is the action start of the read data action with parameters data file. Here, the compliance service issues an alert, meaning it has discovered a violation, and the violation, it happens at rule 2, so rules are numbered somehow. The context is star, meaning that this rule applies to all actions, but then the predicate of this rule expects that the name of the action be one of these two, A or B, whereas the name of this particular action is read data. Okay, so read data is the action that has resulted in the emission of this event. This rule says that the action should have been either A or B. Therefore, here the compliance service detects a violation and it generates this alert compliance report. It also detects a second violation at rule 6, which says that any function, any action except anonymize must be preceded by the anonymized action. And this is indeed a violation because the action that we have executed is read data. Before read data, no anonymized action has been executed. Therefore, this is a violation. Okay, with the same event, as a result of processing the same event, also a compliance, a positive match has been detected. Rule 7 that applies to any context expects or requires that the ADM belongs to the groups that executed this command. This is found right in compliance. So the event right that has received also specifies that the groups under which this action has been executed is ADM, so which means that now we have a match, so this rule is satisfied. And this is the output right of the compliance service. If we go all the way down, all these events, right, so for each of the received monitoring event, it outputs its compliance reports, right? In some cases, right, it also detects that some rules may be, for example, not formulated correctly, in which case, right, it generates exceptions and so on. And right, so this is the output of the compliance service. Since compliance is a service, it runs there and expects more input. So while new data sets are processed and new executions take place, new events are pushed into the Kafka topic UPCAST, and while they are pushed, they are automatically read by the compliance service, and further compliance reports are generated. So, for example, if we attempt another execution now, the monitoring events will be picked by the compliance service, the rules will be applied, and then the compliance reports will be generated. So if we go over here in the MongoDB and we show the collections, before there was only one collection that contained the rules that we pushed to compliance. We'll see that there is a new collection which is called collection.crs1234. So this collection contains compliance reports for each one of the contracts. In this particular case, we attempted a data set execution under contract with number 1234. Therefore, this collection with this contract number has been created in this Mongo collection. So if we try to see what is the contents right of this collection, we can ask collection.crs1234 dot find, and then we get back the same compliance report as a JSON object as we saw before. So this is the compliance output, the output of the compliance service that has been pushed back to the MongoDB. So the same output can be sent to any endpoint that can be configured with the compliance service. And moreover, if we try to see what are the Kafka topics at this point, let's like we did before, UPCAST list, right? And then we see that a new topic, UPCAST CRS, has been created. If we try to see the contents of this topic, we use an UPCAST consumer with the UPCAST CRS topic as a parameter, and then we see that the same monitoring events in somehow less readable form, but at any way have been pushed into this topic. So this completes the demo of the compliance service. We saw how executions result into the emission of monitoring events. We saw how rules can be formulated and pushed into the service, and then we saw how the compliance service picks the monitoring events which are sent by the executions, by the dataset executions. It applies the rules, and then it outputs the compliance reports either back into collections of the backend MongoDB, or to the UPCAST CRS topic, or to any endpoint that has been configured for the collection service to post the same JSON object to that endpoint. So this completes the demo of the compliance service. Thank you for your attendance.
These are the 3 key takeaways of the monitoring and compliance services. 1. Monitoring and compliance is an integral service of any data sharing platform. 2. Monitoring and compliance provides guarantees for the compliance of a dataset execution to the terms of the contract that has been agreed between a dataset provider and a dataset consumer. 3. The UPCAST monitoring and compliance service is a flexible, easily integrable, and deployable service that supports the functions of the UPCAST platform. Details of the monitoring and compliance service are given in UPCAST public deliverables, which can be accessed through the project's website. If you need even more details, feel free to contact us at the address shown at the bottom of this slide. Thank you for taking the time to watch this training session. We hope that you have found it useful.